in feet of a water rocket from the ground is given by this. So this is the distance. It's given in terms of S of t this time. S of t, d of t, these are the common variables for position. Find the expression for the instantaneous velocity of the rocket at any time t. Now it's telling you at any time t. So this is like the homework problems that you did after, where you had to just find the equation for the slope. Okay? So this is going to be the equation for v of t, and it's going to be the limit as h approaches 0 of, instead of f of x plus h, now we're going to have s of t plus h minus s of t over h. So let's do some of this background work here. S of t plus h is going to be 90 t plus h minus 90 t plus, minus 16. There's that 16 again. T plus h squared. So this is going to be 90t plus 90h minus 16 times t squared plus 2th plus h squared.
Okay.
So this is 90t plus 90h minus 16t squared minus 32th minus 16h squared. Okay? And S of t we're given here. So V of t now is the limit as h approaches 0 of this one minus S of t, so it's minus 90t minus plus 16t squared, all over h. All right, we're going to cancel some things out here. What will cancel? So the 90t's will go away. And the 16t squares. And then we can also get rid of some of our h's.
So it's 90 and 32.
All right, so that won't work. All right, so the h is this h with this h with this h.
You cross out 16 with h squared instead of 16. That's why. So then it's just 16 each.
So then you can
So V of t is the limit as h approaches 0 of 90h. No, just 90. Minus 32t. Minus 16h. H. We plug in h as 0 at this point. So we get 90 minus 32t. And that's the right answer. Okay? So this is the expression for the instantaneous velocity at any time. So if you want to check how fast that was going at t equals 2, what would you do? Plug in 2. Okay? That'll give you the...
So can you do that without the number? And then once you, like for the last problem?
Yes, you can.
Plugging in the 7, foiling that big huge thing, you can just do it as t and plug in 7 at the end.
It depends on how the question is asked. So if it was asked in this form, then you would have to do it using that formula. Because it'll test you on the knowledge of the different formulas. Okay? All right. Given the function here, find the average velocity between t equals 1 second and 5 seconds. So this is one that combines everything that we've done. So now we need the average velocity. What was the formula for average velocity?
F times T plus H.
It's
minus-
f of
B.
B
Oh,
minus f of A,
Over.
B minus A. So here V average is f of 5 minus f of 1 over 5 minus 1. So let's see what f of 5 is. It's 3 times 25, 75. And you're not given specific units for the position here, so you can omit units at this point. F of 1 is 3 times 1, 3. So basically, this object was at a position of 75 at 5 seconds, and at 1 second it was 3. So it went from a distance of 3 to 75 in a certain amount of time, in 4 seconds. So this is going to be 75 minus 3 over 4. All right? And look, it went from a distance of 3 to 75. So it looks like it's moving in the positive direction. So our velocity should be positive. Okay? All right, so V average is 75 minus 3, 72 over 4, which is 18. And like I said, if you're not given specific units, then you don't have to. Otherwise, it would have been feet per second, meters per second, miles per second, and so on.
I think units per second, is that okay?
No, don't put any
Cool.
units. The instantaneous velocity, now we need the instantaneous velocity at t equals 4 seconds.
So do we still use the y equals, x squared on this problem?
Right. Now the instantaneous velocity is going to be the limit, so it's v of 4, and it's going to be the limit as h approaches 0 of f of 4 plus h minus f of 4 over h. Let's see what f of 4 plus h is. It's 3 times 4 plus h squared. So it's 3 times 16 plus 8h plus h squared. 48 plus 24 plus 3h squared.
24H.
H. And f of 4 is 3 times 16, 48.
I don't think where the 16 keeps coming from.
It's
4 squared.
it's 4 squared in this case.
Because you take this one.
Okay, so v of 4 is the limit as h approaches 0 of this, so 48 plus 24h plus 3h squared minus 48 over h. The 48s will go away. So will some of the h's. So this h will cancel with this and with this. So finally, I have that v of 4 is the limit as h approaches 0 of 24 plus 3h. Okay? And v of 4 is what? 24. So the average velocity of this object was 18. All right? But we know that at any given time, it may have been 18 or it may have been higher or lower. At t equals 4 seconds, it was higher, it was 24.
So it's
Okay.
slowing down.
Right.
So it could have been a car.
It could have been anything.
Just really quick, what is 24? Like, 24